Okay, so our last quadrilateral that we're going to talk about is called a kite. Okay, so what a kite is it's a quadrilateral with exactly, I'm going to put that word in there, two pairs of adjacent sides that are congruent. Okay, so let's go ahead and draw that picture. So what a kite looks like is exactly what you guys have pictured. All right, so it's going to look like, I'm not very good at drawing them. All right, this, okay? And so you have two sets of sides that are congruent. So these top two, the shorter ones are going to be congruent, and then the bottom ones are going to be congruent as well. All right, so that's a kite. So Theorem 6.25 and Theorem 6.26 are properties of them, okay? And the first one is talking about the first one is talking about the fact that a kite has exactly one set of opposite angles that are congruent, all right? So, and once again, that word exactly. So what I want us to do is draw what that looks like. All right, let's draw a kite. Okay, so one of these are going to be congruent, all right? And sometimes it's just going to take looking at the picture. But do you see how this set of opposite angles, all right, this right here is obtuse and this right here is acute. Obviously, those are not going to be congruent. So they're going to be the ones, all right, that kind of look the same, all right? So these angles right here are going to be congruent, okay? That's the first property. So you have exactly one set of angles that are congruent, okay? Now, Theorem 6.26 is all about the diagonals. So the first one, it says that the diagonals of a kite are perpendicular to one another. And then the other one is that the longer diagonal will bisect the shorter diagonal, okay? So there's two kind of key components in here. So if we draw our kite again, okay, and then this time let's draw on our diagonals. What we know about this is that they are perpendicular, first of all right? So that's those two lines are creating a right angle. And then if you look at the diagonals, you have one long one and you have one shorter one, all right? The long one is going to bisect the shorter one, so that means that this is congruent to this, all right? So that's the properties of the diagonals, all right? So if we go to example 6, it says find the measure of angle F. So here's what we know, okay? The two angles that are shown are not going to be congruent, and we know that we have to have at least one set of opposite angles congruent, which means that angle F has to be congruent to angle H. So to do this, all right, I would take 360 because it's a quadrilateral, and I would subtract 128, and I would subtract 72. Okay, so you're going to do 360 minus 128 minus 72, and what you're going to get is 160 degrees. Okay, so that 160, though, has to be spread apart from F and H, all right? And they have to be congruent, so we're going to take that 160, divide it by 2, which means that both of those angles equal 80 degrees. Okay? Let's do the next one. All right, and I've already given you guys a hint here. So it says that find the length of WZ. Okay, so I gave you the hint that you have to use Pythagorean theorem, but if you remember about Pythagorean theorem, it's dependent on the fact that Pythagorean theorem is only used for right angles, right? Or for right triangles. And that works here because what do we know about the diagonals of a rhombus? Well, what we know is that they are perpendicular. So all of these angles right here are right angles, okay? So for example, this angle right here is a right angle. And so what I want you to look at is the fact that you have this right triangle, you have two of the side lengths, and we need to find that third side length of WZ. So what do we use? All right, we use Pythagorean theorem. So if we're looking at this triangle, which of those sides has to be C? Well, it has to be the one opposite of the right angle, which means that C is my WZ, and then 6 and 8 can be my A and B. All right, so plugging into Pythagorean theorem, we have A squared plus B squared equals C squared. Doesn't matter which one we plug in for A and B, so I'm going to do 6 squared plus 8 squared is equal to C squared. Okay. 6 squared is 36, plus 64 is equal to c squared. 100 is equal to c squared, which means that c is equal to 10. All right, so that means that that length of WZ is 10. Okay. All right, the last two are still just practicing, all right, and we can go over it. So if you look here, it says angle BAD, so this full angle right here is 38 degrees, okay, and angle BCD is 50 degrees. So the congruent angles are always going to be the ones, all right, that are stuck in between the two side lengths that aren't congruent, all right? So like if you notice, BC and AB are not congruent, and same with CD and AD. So they're going to be the angles that are stuck in between the sides that are not congruent, okay? But either way, we still need to find those two angles. These angles right here are going to be the congruent angles, all right? So to find that, what we're going to do is we're going to take 360, subtract 38, and subtract 50, right? And then what we'd get is 272, but that 272 is spread apart two angles, so we have to divide that by 2. And so that means that that angle of angle ADC is 136 degrees. All right. Last one, example 9, says BT is 5. Okay. TC is 8. And what we need to find is CD. Okay. So a couple things here. So we know that these diagonals are perpendicular, so that's a right angle, but we also know that the longer one bisects the shorter one. So if this is 5, this is also 5. Okay? Which means that we are looking to find CD, and CD is the hypotenuse of this right angle, so this is my C. So plugging in to Pythag, all right, we would get 8 squared plus 5 squared, and those are interchangeable, equals C squared. All right, so you get 64 plus 25 is equal to C squared. All right, 89 is equal to C squared, which means that C is equal to the square root of 89, which means that CD, the length of CD, is the square root of 89, and that's your final answer. Okay, so lots of content in this, lots of information about trapezoids, kites, and mid-segments, so make sure you guys do your homework to practice.